Some planets are not terrifying because they are fictional. They are terrifying because they are real. Somewhere in the universe, there are worlds where the sky may glow red from heat. There are planets where clouds can turn into glass, where winds move faster than bullets, where the year is shorter than a day on Earth, where the star is so close that the planet is slowly being pulled apart. There are worlds that never see a sunrise. There are worlds that orbit dead stars. There are worlds wandering alone through the galaxy with no sun, no seasons, no morning, and no reason to ever become warm again. And the strangest part is that these planets are not monsters from a movie. They are not fantasy locations invented to scare us. They are the natural result of gravity, heat, radiation, chemistry, time, and the almost endless variety of ways a planet can be built. Before we begin, if you enjoy calm space documentaries like this, take a moment to subscribe to the channel, leave a like, and write a comment telling us where you are watching from and what time it is right now where you live. It is always strange to remember that while one person is watching under a dark midnight sky, someone else is watching in the middle of the afternoon, and someone else is hearing these words just before sleep. That is one of the quiet things that makes space feel so large. Even on the same planet, under the same sky, we are all experiencing time differently. Tonight, you are watching the Just About Space channel, talking about the most terrifying planets in the universe. And to understand these worlds, we need to begin with one simple idea. A planet does not need life to be interesting. It does not need oceans, forests, cities, or anything familiar. Sometimes the most powerful planets to imagine are the ones that show us what Earth could have been, what Earth avoided, and what the laws of physics are capable of creating when there is no mercy, no protection, and no gentle balance. Earth feels normal to us because we were born here. It has blue skies, breathable air, liquid water, soft clouds, a stable orbit, and a surface where temperatures usually remain within a range the human body can survive. But none of those things are guaranteed. They are not the default state of planets. They are an accident of distance, chemistry, atmosphere, magnetic field, geology, and time. Move a planet too close to its star, and the surface can become an ocean of molten rock. Give it too much atmosphere, and the heat can become trapped until the surface turns into an oven. Place it around a dead star, and radiation can sweep over it like an invisible storm. Throw it out of its star system entirely, and it can drift forever through interstellar darkness. Make it a gas giant, and there may be no ground at all, only deeper and deeper layers of pressure, until hydrogen behaves like metal. Make it dark enough, and it may absorb almost every bit of light that reaches it, becoming a world that is not just night, but almost anti-light. So tonight, we are going to move slowly through some of the most terrifying planets we know about. Not because they are evil, not because they are waiting for us, but because they reveal something unsettling about the universe. The universe can make worlds that look beautiful from a distance and become impossible nightmares the closer you understand them. Before we continue toward the ending, it is worth slowing down and asking how we know any of this, because that may be the most quietly terrifying part of the story. Most of these planets are not worlds we have photographed in detail. We have not sent probes to them. We have not watched their clouds from orbit. We have not lowered landers through their atmospheres. For most exoplanets, we know them through tiny changes in light. A planet passes in front of its star, and the star becomes slightly dimmer, not by much, sometimes by less than 1%. sometimes by so little that the measurement requires extreme precision. But in that tiny fading, astronomers can detect the shadow of a world. This is called the transit method. It is one of the most successful ways humans have found planets beyond the solar system. If the orbit is lined up from our point of view, the planet crosses the face of its star. The star's brightness dips. Then the planet moves on, and the brightness returns. If the dip repeats at regular intervals, astronomers can infer that a planet is orbiting there. From the depth of the dip, they can estimate the planet's size. A larger planet blocks more light. A smaller planet blocks less. From the time between dips, they can determine the orbital period. That tells us how long the planet's year is, and with the star's properties, they can estimate how close the planet orbits, how much radiation it receives, and what kind of temperature range might be possible. That means some of the most terrifying planets in this video began as almost invisible shadows, not images, not maps, not dramatic photographs, just tiny reductions in starlight measured by instruments. Another method is radial velocity. A planet's gravity pulls on its star. The star does not remain perfectly still while the planet orbits. Both star and planet orbit their common center of mass. For a massive planet close to its star, that wobble can be measured. The star's light shifts slightly toward blue when it moves toward us and slightly toward red when it moves away. By measuring that back and forth motion, astronomers can infer the mass of a planet. This is how a hidden planet announces itself without ever being seen. It tugs on its star. The star answers, and across light years, we read that answer. There is also direct imaging, where astronomers block out the glare of a star and try to see the faint planet beside it. This is extremely difficult because stars are enormously brighter than planets. Trying to see an exoplanet near its star can be like trying to see a firefly next to a lighthouse from far away. But for young, hot, massive planets far from their stars, direct imaging can work. Those planets still glow with leftover heat from formation, especially in infrared light. There is microlensing, which feels almost magical. When a star or planet passes in front of a more distant background star, its gravity can bend and magnify the light of the background star. For a brief time, the background star brightens in a particular way. If a planet is present, it can create an extra signal in that brightening. This method can reveal planets far away, including rogue planets that do not orbit stars at all. And then there is spectroscopy. This is where the story becomes even more delicate. When a planet passes in front of its star, a small amount of starlight filters through the planet's atmosphere. Atoms and molecules in that atmosphere absorb specific wavelengths of light. They leave fingerprints. By spreading the light into a spectrum, astronomers can look for those missing wavelengths and infer what the atmosphere may contain. This is how we can begin to talk about water vapor, sodium, carbon dioxide, carbon monoxide, methane, silicates, metals, clouds, haze, and heat on worlds we will never visit. A planet many light years away can reveal its atmosphere because every molecule has a signature. Every gas interacts with light in its own way. So when we say a planet may rain glass, or glow red, or have a lava ocean, or lose atmosphere into space, we are not saying this because a human camera has flown there and filmed it in close-up. We are saying it because light has carried evidence across the void. The universe has written the story in wavelengths. Astronomers have learned to read it. That is why these planets feel so strange. They are both distant and knowable. They are beyond our physical reach, yet not beyond our understanding. A world can be hundreds of light years away, and still we can know that it is too hot, too dark, too close, too massive, or too irradiated for anything human to survive. There is something almost haunting about that. A planet can be invisible to the naked eye, hidden beside a star that itself is only a faint point in our sky, and still it can have weather, it can have winds, it can have chemistry, it can have night side and day side, it can have clouds made of minerals, it can have an atmosphere escaping like smoke, it can be in the middle of a slow death, and we can detect the signs from Earth. This is the power of astronomy. It turns absence into knowledge. It turns a shadow into a planet. It turns a wobble into a mass. It turns a color into a climate. It turns a spectrum into a sky. And that is also why the title of this video matters. The most terrifying planets in the universe are not terrifying because we can stand on them and look around. They are terrifying because we cannot. They are terrifying because even from a distance, with only light and mathematics, they already sound impossible. Now let us slow down even more and ask what actually makes a planet terrifying. The answer is not simply danger. Every place beyond Earth is dangerous to humans. The moon is dangerous. Mars is dangerous. An asteroid is dangerous. Deep space itself is dangerous. But terrifying planets are different because they reveal a kind of planetary extremity. They show one ingredient pushed too far. Heat is one of the simplest ingredients. Move a planet too close to its star, and incoming radiation overwhelms every familiar idea of climate. Water does not remain liquid. Rock may melt. Atmospheres can expand. Molecules can break apart. Metals can vaporize. The surface can become a glowing landscape, or the atmosphere can become a furnace. But heat is not always enough. A hot desert on Earth is uncomfortable, but not cosmic horror. What makes exoplanet heat terrifying is scale. A whole planet can be hot. Not a valley, not a summer day, not a region near a volcano. An entire hemisphere or an entire atmosphere can sit at temperatures where chemistry itself becomes strange. Pressure is another ingredient. Pressure is quiet because we do not usually see it. On Earth, pressure increases underwater, and deep ocean creatures live under forces that would crush us. But gas giants take pressure to a planetary scale. There may be no surface, only descent. Every mile deeper means more material above you, more weight, more compression, more heat. The atmosphere becomes denser until gas turns to liquid-like states. Then deeper layers become stranger. This is terrifying because humans are surface creatures. We evolved on a boundary between rock below and air above. We depend on that boundary. A gas giant removes it. There is no place for the body to understand. No up and down in the familiar sense. No ground. Only falling into increasing pressure until the concept of survival has no meaning. Radiation is another ingredient. Radiation is terrifying because it can be invisible. You can stand under a blue sky on Earth and feel sunlight, but Earth's atmosphere and magnetic field protect you from much of the dangerous high-energy radiation coming from the sun and space. On a planet without those protections, or near a violent star, radiation can strip atmospheres, break molecules, damage DNA, and change the chemistry of the surface. Pulsar planets take this to an extreme. The star they orbit is not a stable, gentle light source. It is a spinning remnant, a compact object with beams of radiation. A planet there exists in the afterlife of a star. The terror is not only physical, it is historical. The system has already passed through catastrophe. Atmosphere is another ingredient. An atmosphere can protect a planet or destroy it. Earth's atmosphere lets us breathe, transports heat, holds pressure, shields us from radiation, and allows liquid water on the surface. Venus shows the other side. An atmosphere can become too thick. It can trap too much heat. It can turn sunlight into a planetary oven. It can create pressure that crushes metal and clouds made of acid. The same word, atmosphere, can mean life or death. On one planet, it is a blanket. On another, it is a prison. Orbit is another ingredient. A planet's orbit decides how much energy it receives, how strong tides are, and sometimes whether the planet can survive at all. A close orbit can make a year last only a day. It can lock one side of the planet toward the star forever. It can allow a star to pull material from the planet's atmosphere. It can bring the planet near the limit where gravity begins to tear it apart. A planet can be doomed by geometry, not by a collision, not by an explosion, just by circling too close. Darkness is another ingredient. We think of darkness as emptiness, but in planetary science, darkness can have different meanings. A rogue planet is dark because no star shines nearby. TRES-2b is dark because it reflects almost no light. The night side of a tidally locked planet is dark because it never turns toward the star. Each darkness has a different cause, but all of them unsettle us. Cold is another ingredient. Extreme cold slows chemistry, freezes gases, hardens surfaces, and turns oceans into shells of ice. But cold becomes most terrifying when it is permanent. An Arctic night ends. A winter ends. A rogue planet's night may not. It may drift for billions of years without a sunrise. Time itself can be an ingredient. Some planetary disasters happen quickly. A meteor impact can change a world in minutes. But many of the most terrifying planets suffer slowly. A star strips atmosphere over millions of years. A close orbit decays over long timescales. A runaway greenhouse develops across planetary history. A rogue planet freezes gradually after ejection. A pulsar planet carries the memory of a supernova long after the explosion has faded. This is why space horror is different from ordinary horror. It is not always fast. It can be patient. It can take longer than civilizations last. It can take longer than species last. It can be written into orbits and chemistry, not screams and shadows. And finally, there is comparison. A planet becomes terrifying when we compare it to Earth. Earth gives us the standard without us noticing. We know what a sky should feel like. We know what a day should be. We know what ground means. We know what rain is. We know what warmth is. Then another planet takes one of those words and changes it. Rain becomes glass. Ground becomes lava. Night becomes eternal. Air becomes acid. A year becomes a day. A sun becomes a dead star. That is the true power of these worlds. They use familiar words, but they fill them with alien meanings. The first terrifying planet is close enough to remind us that hell does not have to be far away. Before we travel hundreds of light years away, we should stop at the planet next door, because one of the most terrifying planets we know is not hiding in another star system. It is Venus, the bright morning and evening star, the object that can look so gentle from Earth that ancient people gave it names connected to beauty, love, and light. From far away, Venus can look peaceful, almost like a pearl suspended near the sun. It is roughly the size of Earth. It has mountains, plains, volcanoes, and a thick atmosphere. In the night sky, it often appears brighter than any star. It is close enough that spacecraft have visited it. Close enough that for a long time, people wondered whether its clouds might hide oceans, jungles, or some strange warm world beneath them. But distance is kind to almost every planet. Distance hides pressure, Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. The reality is much darker. Venus is similar to Earth in size and structure, but its atmosphere is mostly carbon dioxide, and that atmosphere is so thick that the pressure at the surface is more than 90 times the pressure at sea level on Earth. Its clouds are not soft water clouds like ours. They are made of sulfuric acid, and beneath those clouds, the surface temperature is hot enough to melt lead, around 870 degrees Fahrenheit, or about 467 degrees Celsius. This is why Venus belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. A spacecraft descending through the atmosphere of Venus would not simply be entering hot air. It would be entering a crushing ocean of gas. The pressure would rise. The temperature would rise. The light would dim into a yellow-orange gloom. The sky would not be blue. The horizon would not feel open. The world would feel closed, heavy, and suffocating, as if the atmosphere itself were pressing down with the weight of an ocean. Even machines struggle there. The Soviet Venera landers reached the surface and sent back images, but they survived for only a short time before the heat and pressure destroyed them. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The terror of Venus comes from the greenhouse effect taken to an extreme. Sunlight reaches the planet, passes through the upper atmosphere, and warms the surface. The surface tries to radiate heat back into space as infrared radiation. But carbon dioxide absorbs much of that infrared energy and re-emits it, trapping heat inside the atmosphere. On Earth, this same basic effect helps keep the planet warm enough for life. On Venus, it became runaway. The system pushed itself into a state where heat could not escape efficiently, and the entire surface became an oven. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. A person on Venus would never walk across the ground. A suit would need to resist crushing pressure, chemical clouds, and a temperature hotter than a kitchen oven by several times. Ordinary metal would weaken. Electronics would fail. Human skin, lungs, blood, and bone are not built for a world where the air itself is dense, toxic, acidic, and scorching. Even if you could somehow stand there for a moment, the landscape would not be welcoming. It would be a volcanic world under a permanent cloud ceiling, with a sky that never clears and a surface that has been cooked for billions of years. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like Venus are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. Venus is terrifying because it looks like a version of Earth that went wrong. It is not a gas giant. It is not a distant alien world around a strange star. It is rocky, nearby, and almost Earth-sized. That makes it more disturbing. It shows that being in the inner solar system, being rocky, and being similar in size to Earth is not enough. The details matter. Atmosphere matters, distance matters, water matters, climate feedback matters. A planet can begin with promise and still become a furnace. So when we look at Venus, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. Before we leave our solar system, Venus gives us the emotional foundation for the rest of the journey. It tells us that planets are delicate arrangements. Change the balance and beauty can become brutality. The second terrifying planet is not terrifying because it is hot, but because it has no surface to save you. Jupiter is familiar. We have seen its striped clouds in textbooks, telescope images, and spacecraft photographs. It is the giant of the solar system, larger than all the other planets combined. A world so massive that it almost feels like a failed star, though it was never truly close to becoming one. From far away, Jupiter looks majestic. Its bands curve around the planet in shades of cream, rust, orange, and brown. The Great Red Spot, a storm larger than Earth, has been raging for centuries. From far away, Jupiter can seem like a painted marble, beautiful and orderly, with moons circling it like a miniature solar system. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. But Jupiter is not a place you land on. It is mostly hydrogen and helium. There is no solid surface waiting beneath the clouds in the way most people imagine. If you fell into Jupiter, you would pass through cloud layers and gases that grow denser and hotter as you descend. Pressure would increase until hydrogen gas becomes liquid, and deeper still, the pressure becomes so intense that hydrogen may behave like an electrically conducting metal. This is why Jupiter belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terrifying thing about Jupiter is the absence of a stopping point. On Earth, falling means eventually hitting ground. On Jupiter, falling means being swallowed by an atmosphere that becomes an ocean, then something stranger than an ocean, then a crushing interior where the distinction between atmosphere and planet begins to disappear. There is no beach, no mountain, no cave, no safe shelter. There is only depth. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. Jupiter's terror comes from mass. Gravity gathers material. Material creates pressure. Pressure changes matter. The deeper you go, the more the weight of everything above you presses inward. On Earth, our atmosphere feels light because we live at the bottom of a thin layer of air. On Jupiter, the atmosphere is the planet. It is thousands of miles of gas becoming fluid, fluid becoming metallic, and pressure turning familiar elements into unfamiliar states. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. A human explorer would not survive long enough to understand the descent. Long before reaching anything like a deep interior, the pressure would crush any normal structure. The temperature would rise. Winds would tear through the upper layers. Radiation near Jupiter is also intense because Jupiter has a powerful magnetic field that traps charged particles. Even spacecraft must be carefully protected. NASA's Juno mission follows a special orbit, partly to survive Jupiter's radiation environment while studying the planet. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like Jupiter are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. Imagine falling into a world where the sky never ends. The clouds above you become darker. The pressure squeezes from every direction. The wind is not simply blowing across a surface. It is part of a planet-sized engine. Below you, there is no ground, only more atmosphere, then denser atmosphere, then fluid, then physics you cannot recognize with human senses. And once you understand Jupiter, the gas giants around other stars become even more frightening, because some of them are Jupiter-like worlds placed so close to their stars that the entire planet becomes a furnace. So, when we look at Jupiter, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. Jupiter teaches us that not every planet is a world in the human sense. Some planets are not places. They are vast gravitational structures. They are weather systems the size of worlds. They are pressure machines. They are laboratories where matter is transformed by weight alone. And yet Jupiter is still a planet. That is the unsettling thing. The word planet can mean Earth, with forests and oceans, but it can also mean Jupiter, with no solid surface and an interior that would erase anything that entered it. The third terrifying planet is a world so hot that molecules themselves begin to come apart. Far beyond our solar system, about hundreds of light years away, there is a planet called KELT 9b. It is a gas giant, larger than Jupiter, but its location makes it almost impossible to compare with Jupiter emotionally. Jupiter is cold compared to it. Jupiter is distant from the sun. Jupiter has a kind of slow majesty. KELT 9b is different. It is a planet trapped in the glare of a star so hot that the planet is being cooked at temperatures more familiar to stars than to worlds. From far away, KELT 9bi would not look like a calm blue marble or even a familiar striped gas giant. It would be a swollen, irradiated world near a blazing star, glowing under an amount of stellar energy that no human environment could begin to withstand. Its star is much hotter than our sun, and the planet orbits incredibly close to it, completing a year in only about 1.5 Earth days. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. NASA describes Kelt 9b as so hot that the heat tears molecules apart on its day side. It is a gas giant with a radius nearly twice Jupiter's, a mass a few times that of Jupiter, and an orbit only a tiny fraction of Earth's distance from the Sun. The day side of the planet is heated to thousands of degrees. At such temperatures, normal atmospheric chemistry starts to fail. Molecules that would exist on cooler planets are ripped apart by heat and radiation, then may reform when winds carry material to the cooler night side. This is why Kelt 9b belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terrifying image is not just a hot planet. It is a planet where the atmosphere itself cannot remain chemically whole. The day side is not weather in any Earth-like sense. It is a region where radiation from the star drives the atmosphere into an extreme state. Hydrogen molecules can split into atoms. Metals can exist as vapor. The boundary between planet and star feels emotionally blurred, even though Kelt 9b is absolutely a planet. It is a world being forced to behave like something closer to a stellar furnace. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The science behind Kelt 9b begins with orbital distance and stellar temperature. The closer a planet is to its star, the more radiation it receives. And if the star itself is hotter than the Sun, the effect becomes even more extreme. Kelt 9b orbits so close that it is likely tidally locked, with one side constantly facing the star and one side facing away. On the day side, energy pours down without relief. On the night side, the atmosphere may cool enough for some molecules to temporarily reform. Then circulation drags material back into the day side, and the process begins again. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. A human could not meaningfully approach this planet. Before atmospheric pressure or gravity became the issue, radiation and heat would be the problem. Any spacecraft close enough to skim the day side would need protection far beyond ordinary planetary mission design. The star would dominate the sky. The planet would not offer shelter. There would be no surface, no shadowed valley, no cold night to escape to in any normal sense. Even the night side, cooler by comparison, would still be violently hot by human standards. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like Kelt 9b are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. What makes Kelt 9b so important is that it teaches us how far planetary atmospheres can be pushed. On Earth, we think of an atmosphere as air, wind, clouds, weather, and climate. On Kelt 9b, an atmosphere is also chemistry under attack. It is a substance being heated, broken, dragged, cooled, reassembled, and broken again. The planet is not just hot, It is a machine for testing the limits of planetary identity. And after KELT 9b, we should look at another world that sounds almost beautiful at first, until you realize that its beauty is made of lethal weather. So when we look at KELT 9b, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. KELT 9b also reminds us that some planets are temporary. Close-in worlds can lose atmosphere. Their stars can strip material from them. Their orbits can decay. Their futures are not peaceful. A planet can be massive and still be vulnerable. A gas giant can be enormous and still be slowly changed by a star it orbits too closely. The fourth terrifying planet is blue like Earth, but that is where the similarity ends. HD 189733b is one of the most famous nightmare exoplanets because it tricks the imagination. When scientists studied its light, they found that the planet appears deep blue. And for a moment, that sounds comforting. Blue makes us think of oceans. Blue makes us think of Earth from space, a living world wrapped in atmosphere and water. From far away, HD 189733b may look like a calm blue sphere, a jewel orbiting its star. If you only knew its color, you might imagine skies, seas, and a world reflecting gentle light. It is close enough, bright enough, and well-studied enough that it has become one of the classic examples of how misleading beauty can be in astronomy. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. NASA describes HD 189733b as a scorching alien world where winds can blow up to about 5,400 miles per hour, and where silicate particles in the atmosphere may create glass-like rain moving sideways through the winds. It is a hot Jupiter, a gas giant orbiting very close to its star. Its blue color does not come from water oceans. It likely comes from particles in its atmosphere scattering blue light. This is why HD 189733b belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terrifying part is the weather. Not rain as we know it. Not water falling gently from clouds. Imagine particles of glass or silicate material driven around a gas giant by winds moving many times faster than the strongest hurricanes on Earth. The phrase raining glass sideways sounds impossible until you remember that planets are not required to match our categories. A cloud does not have to be water. A sky does not have to be breathable. Rain does not have to be liquid water. It can be chemistry falling through an atmosphere under forces no human body could survive. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The science begins with heat and speed. Hot Jupiters orbit extremely close to their stars. Their atmospheres are heated intensely on the day side. Temperature differences between regions can drive powerful winds. Because these planets are gas giants, there is no familiar solid surface to slow the flow in a simple way. The atmosphere becomes a global engine, transferring heat, carrying particles, and producing weather that makes Earth's storms seem small. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. A human explorer descending into HD 189733b would be entering a blue death. The color would not mean safety. There would be no ocean to land beside. There would be no gentle sky. The winds would be faster than any aircraft humans normally build. The pressure would increase with depth. The temperature would be extreme. And if silicate particles were suspended in the atmosphere, they would not be romantic glitter. They would be a storm of sharp, hot mineral material moving at devastating speeds. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like HD 189733b are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. The reason HD 189733b is so memorable is that it attacks one of our deepest assumptions. We associate color with familiarity. Blue means water. White clouds mean weather. Bright planets mean beauty. But HD 189733b tells us that the universe can imitate familiar appearances while hiding completely alien causes. A blue planet can be a place where the rain would slice through anything delicate. A bright world can be a lethal one. Beauty is not the same as habitability. And once we understand that a blue world can rain glass sideways, the word planet becomes stranger again. It no longer means a place like Earth. It means a natural object large enough to have an atmosphere, gravity, chemistry, and history. And those ingredients can combine into almost anything. So, when we look at HD 189733b, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. This planet also teaches astronomers how much we can learn from light. We have never visited HD 189733b. No probe has entered its atmosphere. Yet by studying the starlight that passes through or reflects from the planet, scientists can infer properties of its atmosphere, its color, its winds, and its chemistry. This is one of the miracles of modern astronomy. We can learn about weather on a planet many light years away because atoms and molecules leave signatures in light. The fifth terrifying planet is a rocky world that may have a global ocean, but not an ocean of water. 55 Cancri E, also called Janssen, is a super-Earth orbiting a star about 41 light-years away. The phrase super-Earth can sound hopeful at first. It makes people imagine a larger Earth, maybe a planet with bigger mountains, deeper oceans, or stronger gravity. But in astronomy, super-Earth only means a planet larger than Earth and smaller than Neptune. It says nothing about whether the world is friendly. From far away, 55 Cancri E is not visible to our eyes as a separate world. It is known through careful measurements, through the way its gravity and transit reveal its presence. But if you imagine it up close, it is one of the most dramatic rocky planets we know. It orbits extremely close to its star, far closer than Mercury orbits our Sun, and completes a full year in less than 18 hours. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. NASA's exoplanet catalog describes 55 Cancri E as a super-hot super-Earth with a global ocean of lava and sparkling skies. It has a mass around 8 times Earth's and a radius less than twice Earth's. Its orbit is so tight that the star would dominate the sky. The planet is likely extremely hot, and observations with the James Webb Space Telescope have suggested that it may even have an atmosphere produced or replenished by gases coming from its molten surface. This is why 55 Cancri E belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terror here is that 55 Cancri E is rocky, and that makes it feel closer to us. A gas giant is obviously alien, but a rocky planet invites the imagination to search for ground. And there may be ground on 55 Cancri E, but it would be ground transformed by heat into something hostile. On the day side, rock can melt. The surface may behave like lava. Clouds, if they exist, may be made from minerals or vaporized material. The sky could sparkle not because it is gentle, but because it is filled with exotic particles and heat-driven chemistry. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The science of 55 Cancri E is the science of proximity. A rocky planet close to its star absorbs enormous energy. If it is tidally locked, one hemisphere may always face the star while the other remains in permanent darkness. That creates dramatic temperature differences. Heat may circulate through an atmosphere if one exists, or through a magma ocean if molten rock can flow. The surface may be partly molten, partly solid, and constantly shaped by the balance between incoming radiation and outgoing heat. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. A human on 55 Cancri E is not a realistic image, but it helps us feel the scale. Imagine a sky where the star looks enormous. Imagine a horizon glowing not with sunset, but with heat from the ground itself. Imagine rock that is not solid under your feet because the surface has been softened or melted by stellar radiation. Imagine an atmosphere that might be thin, poisonous, heavy with volcanic gases, or repeatedly stripped and remade by the planet's own molten interior. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like 55 Cancri E are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. What makes 55 Cancri EA especially fascinating is that it is not simply a dead rock. It may be geologically and atmospherically active in ways we are still learning to understand. The planet may lose atmospheric material and regain it from volcanic outgassing. Its surface and sky may be connected in a cycle of melting, evaporation, condensation, and return. It is a rocky world, but the rock itself becomes part of the weather. And if 55 Cancri E shows us a rocky planet being melted by its star, the next world shows us a gas giant being stretched and torn apart by one. So when we look at 55 Cancri E, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. 55 Cancri E teaches us that rocky planets can be stranger than gas giants. On Earth, rock feels stable. Mountains feel permanent. Lava is an exception, something that erupts from beneath the crust. But on a planet like this, molten rock may not be an exception. It may be the landscape. The planet takes the most solid thing we know and turns it into something that flows. Now let us talk about the one thing almost every terrifying planet in this video has in common. They force us to separate appearance from reality. Venus appears bright and beautiful from Earth, but beneath its clouds, the surface is a pressure cooker. HD 189733b appears blue, but its blue does not mean oceans. Tris 2b orbits a star, but instead of reflecting that star's light, it absorbs almost all of it. 55 Cancri E is rocky, but rocky does not mean solid, cool, or Earth-like. WASP 12b is a planet, but planet does not mean stable. Jupiter has clouds, but clouds do not mean there is ground below them. This is one of the most important lessons in astronomy. The universe often gives us familiar shapes with unfamiliar causes. A sphere does not mean safety. A blue color does not mean water. A cloud does not mean rain. A star does not mean gentle warmth. A planet does not mean a place. We are trained by Earth to interpret the universe through earthly symbols. Blue is water. White is cloud. Green is life. Dark is cold. Rock is solid. Air is breathable. Day is warm. Night is temporary. But other planets break these associations. They take the same visual language and rewrite the meaning. On a hot Jupiter, clouds could be made from minerals or metals. On a lava planet, the surface could glow with molten rock. On a gas giant, the atmosphere could continue downward until pressure destroys the distinction between sky and interior. On a rogue planet, night could last for billions of years. On a pulsar planet, the central light source could be the rotating corpse of a star. On a dark planet, the absence of reflection could hide intense heat. This matters because the search for habitable worlds is partly a fight against assumptions. A planet may be Earth-sized and still not be Earth-like. It may be in the habitable zone and still have no liquid water. It may have an atmosphere and still be hostile. It may have water vapor and still be too hot. It may have clouds and still be poisonous, acidic, or crushing. It may look promising in one measurement and terrifying in another. Astronomers have learned to be careful with language. When a planet is called Earth-like, it usually means something narrow, such as size, mass, or orbital distance. It does not mean forests. It does not mean oceans. It does not mean life. It does not mean a sky you could breathe under. A super-Earth is not necessarily a better Earth. It may be a lava world, a mini Neptune with a thick atmosphere, a dense rocky planet under crushing gravity, or something in between. A habitable zone planet is not necessarily habitable. It may have no atmosphere. It may have too much atmosphere, it may be tidally locked, it may orbit a flaring star, it may have lost its water long ago. This is why terrifying planets are useful. They teach caution. They remind us that a single label can hide an entire world of complexity. And this is also why the future of exoplanet science is so exciting. The next step is not just finding planets, it is characterizing them. It is moving from the question, is there a planet there, to the deeper question, what kind of planet is it? What is its atmosphere made of? Does it have clouds? Does it have a surface? How hot is it? Does heat move from one side to the other? Is the atmosphere escaping? Does the planet reflect light or absorb it? Is there water? Is there carbon dioxide? Is there methane? Is there oxygen? Are those gases in balance or out of balance? Could the chemistry be explained by geology, or does it suggest biology? Each of these questions requires patience. Each requires observations at the edge of what our instruments can do. And sometimes the answers will disappoint us. A world that looked promising may turn out to be dry. A world in the habitable zone may have a thick hydrogen envelope. A rocky planet may be airless. A possible ocean world may be too hot. A planet once imagined as Earth-like may become another entry in the list of terrifying worlds. But that is not failure. That is discovery. The universe is not obligated to give us second Earths quickly. It gives us reality, and reality is more interesting than wishful thinking. The terrifying planets are part of that reality. They are the warnings at the edges of habitability. They show what happens when a variable is turned too far. Too much heat, too much atmosphere, too much pressure, too much radiation, too much darkness, too much closeness, too much gravity, too little sunlight, too little protection, too little stability. And between all those extremes lies the narrow range where life as we know it might survive. That is the quiet structure beneath this entire video. We are not just touring nightmares, we are mapping the boundaries of life. The sixth terrifying planet is not just orbiting its star, it is being destroyed by it. WASP-12b is one of those planets whose story sounds almost too dramatic to be real. It is a hot Jupiter orbiting so close to its parent star that the planet completes one orbit in only about 1.1 Earth days. A year there is shorter than many weekends on Earth. From far away, from a distance, WASP-12b would not be a neat sphere like Jupiter in a textbook. It is likely distorted by tidal forces, stretched by the gravity of its star. The star pulls on the near side of the planet more strongly than the far side, creating a tidal distortion. In some artistic interpretations, the planet looks almost egg-shaped, as if the star is drawing it outward. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. NASA describes WASP-12b as a doomed planet, a hot Jupiter orbiting so close to its parent star that it is being torn apart. The planet is larger than Jupiter and orbits at a tiny fraction of the distance between Earth and the Sun. Its atmosphere is heated, swollen, and vulnerable to being stripped away into space. This is why WASP-12b belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terror of WASP-12b is not just the temperature. It is the fact that the planet is in a hostile gravitational relationship with its own star. The star is not simply shining on it. It is deforming it. It is pulling at it. It may be removing material from it. The planet is massive, but it is too close to something far more powerful. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The science behind this is tidal force and atmospheric escape. Gravity weakens with distance. When a planet orbits very close to a star, the side facing the star feels slightly stronger gravity than the side facing away. For close-in planets, that difference can be enormous. If the planet fills or nearly fills a region called its Roche lobe, material can escape more easily from the planet's outer layers. The star can effectively steal gas from the planet. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. A human perspective here is almost impossible because there is no surface to stand on and no safe orbit nearby. The star would dominate everything. The planet's upper atmosphere would be inflated by heat. The gas around it may be escaping. The entire environment would be filled with radiation, gravitational stress, and extreme temperatures. You would not be visiting a stable planet. You would be approaching a world in the process of losing itself. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like WASP-12b are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. WASP-12b is frightening because it makes planetary destruction feel quiet. It is not an explosion in a single instant. It is not a planet shattering like glass. It is a slow cosmic punishment. Orbit after orbit, day after day, year after one-day year, the planet remains too close. The star keeps pulling. The heat keeps swelling the atmosphere. The system keeps evolving. And from a doomed planet glowing near its star, we now turn to a world that terrifies in the opposite way, not because it is too bright, but because it is almost impossible to see. So when we look at WASP-12b, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. This teaches us that planets are not always permanent objects. We often think of planets as stable things, circling stars for billions of years. But some orbits are dangerous. Some planets are born or driven inward until their own star becomes their destroyer. A planet can be doomed not by a collision, but by proximity. The seventh terrifying planet is darker than coal. TRES-2b is sometimes called the darkest known exoplanet orbiting a star. It is a gas giant, similar in broad category to Jupiter, but it does something that feels deeply unnatural to the human imagination. It reflects almost none of the light that reaches it. From far away, TRES-2b would not shine like Venus. It would not gleam like Jupiter. It would be a nearly black sphere close to its star, absorbing light instead of sending it back into space. NASA describes it as the planet of eternal night, less reflective than coal, with some scientists thinking an eerie, deep red glow could come from its burning atmosphere. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. The measured darkness of TRES-2b is difficult to picture. Most planets reflect at least some of the light they receive. Earth reflects light from clouds, ice, land, and ocean. Jupiter reflects sunlight from bright clouds. Venus is brilliant because its thick cloud cover reflects a great deal of sunlight. TRES-2b is different. Its atmosphere may contain chemicals that absorb light efficiently, and its high temperature may prevent reflective clouds from forming. This is why TRES-2b belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terror of TRES-2b is psychological as much as physical. A planet that absorbs nearly all light feels wrong to us because planets are usually seen by reflection. They glow in the night sky because they borrow light from their stars. But TRES-2b seems almost to swallow that light. It does not become invisible exactly because heat can make it glow faintly red. But the idea of a giant planet darker than coal orbiting a star is unsettling. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The science involves albedo, the measure of how much light a body reflects. A high albedo object reflects a lot of incoming light. Snow is bright because it has a high albedo. Charcoal is dark because it absorbs most light. TRES-2b has an extremely low albedo. Its atmosphere may lack bright reflective clouds, and compounds like vaporized sodium, potassium, or titanium oxide may absorb incoming light. Meanwhile, the planet is hot enough that it emits thermal radiation of its own. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. If a human somehow approached TRES-2b, the darkness would not mean cold. That is the trap. On Earth, darkness often means night, and night often means cooling. On TRES-2b, darkness can coexist with extreme heat. The atmosphere can absorb light and still be violently hot. The planet may glow like a coal from within, not because it is gentle, but because it is burning with absorbed energy. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like TRES-2b are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. This world teaches us that darkness in space is not always emptiness. Sometimes darkness is absorption. Sometimes a planet is dark because it is catching light and refusing to give it back. And that idea changes how we imagine the night. A black planet is not necessarily a frozen planet. It can be a heated atmosphere hiding behind its own lack of reflection. And after a planet of eternal night, the next worlds are terrifying because they orbit something that should not be a sun at all. So, when we look at TRES-2b, we are not just looking at a strange world far away, we are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. TRES-2b also shows how alien atmospheric chemistry can be. On Earth, clouds brighten the planet. On other worlds, high temperatures can remove clouds, change molecules, and create atmospheric layers that drink in starlight. The appearance of a planet is not only about its surface. It is about the chemistry of the air, the temperature of the upper atmosphere, the wavelength of the star's light, and the way all of these things interact. The 8th terrifying worlds orbit a dead star. In the early 1990s, astronomers confirmed some of the first planets ever found beyond our solar system. But they were not discovered around a friendly star like the Sun. They were discovered around a pulsar, a rapidly rotating neutron star, the collapsed remnant of a massive star that had exploded. From far away, a pulsar system would not look like a calm solar system. The central object is not a warm yellow sun. It is a dead stellar core, incredibly dense, spinning rapidly and emitting beams of radiation. If those beams sweep across Earth, we detect pulses, like the ticks of a cosmic clock. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. NASA's exoplanet catalog describes PSRB 1257 plus 12b and its neighboring worlds as among the first and creepiest exoplanets discovered. They orbit an undead star known as a pulsar. Pulsar planets like Poltergeist, Phobetor, and Draugr are exposed to intense radiation from the star's core. The system includes planets found through pulsar timing, using tiny changes in the regular pulses to reveal the gravitational tug of orbiting worlds. This is why the planets of PSRB 1257 plus 12 belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terror of pulsar planets is hard to express because the central star changes the emotional meaning of a planetary system. Around the sun, planets receive light and warmth. Around a pulsar, a planet receives radiation from the corpse of a star. The star has already died violently. Any original planets may have been destroyed in the supernova, or the system may have formed again from debris afterward. Either way, the result is a planetary system around a stellar remnant that should feel impossible. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The science begins with neutron stars. When a massive star runs out of fuel, its core can collapse under gravity. Protons and electrons are squeezed together into neutrons. The result is an object with more mass than the Sun, compressed into a sphere only about the size of a city. Conservation of angular momentum can make it spin incredibly fast. Magnetic fields and rotation create beams of electromagnetic radiation. When those beams point toward us, the star appears to pulse. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. A planet near such an object would not experience sunlight in the familiar sense. It would be bathed in high-energy radiation, charged particles, and the influence of an extreme magnetic environment. The surface, if rocky, would be exposed to conditions hostile to chemistry as we know it. The sky would not contain a gentle sunrise. It would contain the pulse of a dead star sweeping through space. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like the planets of PSRB 1257+12 are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. Imagining a human there is not like imagining an astronaut on Mars. Mars is cold, dusty, and difficult, but it is still a planet under ordinary sunlight. A pulsar planet is different. The central star is a compact remnant with a history of catastrophic death. Any world orbiting it carries that history in its existence. It is not just a planet. It is a survivor, or a second-generation world built from wreckage. And after planets around a dead star, we should move to the loneliest planets of all, worlds that do not orbit any star. So when we look at the planets of PSRB 1257+12, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. These planets teach us that planet formation can happen in places astronomers once did not expect. If planets can exist around pulsars, then planetary systems are more resilient and stranger than we imagined. Worlds can form or remain after stellar death. The universe does not stop making planets just because a star has become a corpse. The 9th terrifying planets have no sun. A rogue planet is a world that wanders through space without orbiting a star. Some may have formed around stars and later been thrown out by gravitational interactions with other planets. Others may have formed more like tiny failed stars, directly from collapsing gas and dust. But emotionally, the result is the same. A planet, alone in interstellar darkness. From far away, most rogue planets would be almost invisible. Without a nearby star, they do not shine by reflected light. Young ones may glow faintly in infrared from leftover heat, but older rogue planets would be cold, dark, and nearly impossible to detect unless they pass in front of a background star and briefly bend its light through gravitational microlensing. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. NASA explains that most exoplanets orbit other stars, but some free-floating exoplanets, called rogue planets, are untethered to any star. Astronomers have confirmed thousands of exoplanets, and the galaxy may contain vast numbers of rogue worlds. These planets are difficult to find because they are not part of a bright system. They are not revealed by regular transits across a star or by a star wobbling under their gravity in the usual way. This is why Rogue Planets belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terror of a rogue planet is quiet. There may be no sunrise, ever. No year in the familiar sense. No seasons caused by orbiting a star. No bright star growing larger or smaller in the sky. Just the distant background of the galaxy and the cold cosmic microwave background. If the planet has an atmosphere, it may freeze. If it has oceans, they may become ice. If it has internal heat, it may hide warmth deep below the surface. But from outside, it would appear like a dark body drifting through a vast night. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The science of rogue planets begins with the chaos of planet formation. Young planetary systems are not always stable. Giant planets can scatter smaller worlds. Close encounters can sling planets outward at high speed. A planet that once formed in a disk around a newborn star can be gravitationally ejected, leaving the system forever. Once that happens, the star becomes just another point of light behind it. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. A human on a rogue planet would experience a kind of darkness no one on Earth truly knows. Even the darkest night on Earth belongs to a planet orbiting a star. Dawn is coming. The atmosphere holds memory of sunlight. The climate is powered by solar energy. On a rogue planet, there may be no dawn at all. Time would not be measured by sunrise and sunset. The sky might be filled with stars, but none of them would be close enough to warm the surface. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like rogue planets are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. And yet rogue planets are not necessarily simple frozen rocks. If a rogue planet is massive enough, it could retain a thick atmosphere that traps internal heat. If it has radioactive decay or tidal heating from a moon, it could maintain subsurface liquid water. Some scientists have speculated about the possibility of life in hidden oceans beneath ice, even without a star. That idea is both hopeful and eerie. Life, if it existed, would not know daylight. It would live by chemistry and internal heat, in darkness older than any sunrise. And after imagining planets without stars, we can return to planets that do have stars, but where the star creates a different kind of nightmare. So when we look at rogue planets, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. Rogue planets teach us that a planet's identity does not depend entirely on its star. A world can be a planet without a sun in its sky. But they also remind us how much Earth depends on the sun. Remove our star's light, and Earth would begin freezing quickly. The oceans would freeze from the top downward. The atmosphere would eventually change. Our biosphere would collapse, except perhaps in deep environments powered by internal heat. Let us also imagine the sound of these worlds, even though most of them would not sound the way we expect. Sound needs a medium. It needs atoms or molecules to carry pressure waves. In the vacuum of space, there is no ordinary sound. But inside an atmosphere, sound can exist. And on some of these planets, the atmospheres are so different from Earth's that sound itself would behave strangely. On Venus, the dense carbon dioxide atmosphere would carry sound differently from Earth's air. Because the atmosphere is thick and hot, sounds might travel in a heavy, distorted way. The wind near the surface may be slow compared with the upper atmosphere, but the environment would feel oppressive. Not silent exactly, but muffled by density. A world of pressure, heat, and chemical haze. On Jupiter, if you could place a protected microphone in the upper atmosphere, you might hear winds and turbulence, but there would be no solid landscape to echo from in the familiar way. Deeper down, pressure would change everything. The medium itself would become denser. The idea of sound would merge with the physics of a fluid planet. On HD 189733b, the winds are so violent that imagining sound almost becomes meaningless. A 5,000-mile-per-hour wind is not a breeze, not a storm, not even a hurricane in the ordinary sense. It is a global atmospheric current moving with devastating speed. If there were particles of silicate or glass-like material in that flow, the atmosphere would be not just air, but abrasion. The sound, if any instrument could survive to record it, might be a continuous roar beyond human scale. On a rogue planet with no thick atmosphere, there may be no sound at all. A rock cracking from thermal stress would make no noise if no air carried the vibration outward. A meteor striking the surface would be silent beyond the vibration through the ground. The world would be dark, cold, and mute. On a pulsar planet, the most terrifying sound would not be sound at all. It would be rhythm, the rhythm of the pulsar, the star's beams sweeping through space with extraordinary regularity. Radio pulses arriving like the ticking of a cosmic clock, a dead star keeping time over a dead world. Thinking about sound helps us understand something subtle. A planet is not only terrifying through what it looks like, it can be terrifying through what it lacks. No sound, no sunrise, no surface, no water, no stable sky, no safe pressure, no gentle weather, no familiar chemistry. Humans depend on the presence of certain things and the absence of others. We need air, but not too much pressure. We need warmth, but not too much heat. We need radiation from the sun, but not unfiltered high-energy radiation. We need gravity, but not crushing gravity. We need water, but not molten rock. We need darkness to sleep, but not eternal starless night. A terrifying planet is often one where the balance is broken. Something essential is missing, or something dangerous is overwhelming. This is why the most frightening worlds are not always the most dramatic looking. A completely dark rogue planet may not have lightning, lava, or glowing storms. But the absence of a star is enough. A gas giant may look beautiful from orbit, but the absence of ground is enough. A blue exoplanet may look inviting, but the difference between blue light and blue water is enough. A planet in the habitable zone may look promising, but the absence of a stable atmosphere is enough. The universe is full of absences, and sometimes absence is more terrifying than violence. No air, no dawn, no shelter, no return. The 10th terrifying planets are the ice giants, because even familiar planets can hide impossible interiors. Neptune and Uranus are sometimes treated as quiet blue worlds at the edge of the solar system. They are far away, cold, and less visually dramatic than Saturn's rings or Jupiter's storms. But the more you think about them, the stranger they become. They are not just cold outer planets. They are pressure worlds where matter may behave in ways that sound almost mythological. From far away, Uranus and Neptune look serene. Uranus is pale blue-green. Neptune is a deeper blue, dark and distant. Sunlight out there is weak. On Neptune, high noon would look like dim twilight compared to noon on Earth. These worlds seem calm because they are far away from the violent heat of the inner solar system. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. NASA describes Neptune as dark, cold, and whipped by supersonic winds, more than 30 times farther from the Sun than Earth. NASA has also discussed the possibility that on Uranus and Neptune, temperature and pressure conditions are so extreme that carbon atoms could be crushed into diamonds in their atmospheres. This is often described as diamond rain, though the detailed physics of their interiors is still an active area of research. This is why Neptune and Uranus belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terror of Neptune and Uranus is not that you would burn. It is that you would descend into a world where pressure becomes the main force of destruction. These planets do not offer solid ground at the cloud tops. Their atmospheres and interiors transition through layers of hydrogen, helium, methane, water, ammonia, and other materials under extreme compression. Deep below the visible clouds, chemistry and physics change. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The science here is pressure, temperature, and composition. Carbon-rich compounds like methane may break apart under intense pressure. Carbon atoms could be forced into diamond structures, and those diamonds may sink deeper into the planet, like a kind of rain through exotic interior layers. Whether the process happens exactly as imagined in popular descriptions is still studied, but the broader point is real. The interiors of ice giants are places where ordinary materials are transformed by extreme conditions. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. A human descending into Neptune would face cold in the upper atmosphere, then crushing pressure, then rising heat, then chemical layers no body or spacecraft could tolerate for long. Winds in Neptune's atmosphere can reach supersonic speeds. There is no solid surface where a lander could open a hatch. There is no safe ocean. There is no rocky floor waiting conveniently below the clouds. Like Jupiter, Neptune is a world of increasing depth, but with different chemistry and different mysteries. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like Neptune and Uranus are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. These worlds are terrifying because they are familiar names from our own solar system, yet they remain deeply unknown. We have visited them only briefly with Voyager 2. Most of what we know comes from remote observations and models. That means Uranus and Neptune are not only physically strange, but scientifically unfinished. They sit in our own solar system like unsolved riddles. And from these cold pressure worlds, we now return to the category that may be the most common nightmare in the galaxy: planets orbiting too close to their stars. So when we look at Neptune and Uranus, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. They teach us that distance can make worlds look simple. A blue dot is easy to label, but beneath that color may be winds, pressure, chemical rain, strange magnetic fields, and interior layers that humans have never touched. The solar system is not made of simple objects. Even the planets we can name from childhood contain environments that would destroy us instantly. The 11th terrifying planets are the worlds where one side may live in eternal day and the other in eternal night. Not every terrifying planet needs a famous name. Some terror comes from a category. Across the galaxy, many planets orbit small, dim red dwarf stars. Because those stars are cooler than the sun, their habitable zones are much closer in. A planet must orbit near the star to receive enough warmth. But when a planet orbits close enough, tidal forces can slow its rotation until one side always faces the star and one side always faces away. From far away, a tidally locked planet might look divided. One hemisphere facing the star could be bright and hot. The other could be dark and cold. Between them, there might be a permanent twilight zone, a ring around the planet where the star hangs near the horizon forever. This sounds almost poetic, but it could be extremely hostile depending on the planet's atmosphere, oceans, magnetic field, and star. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. The facts vary from world to world because tidal locking is not a single planet, but a possible state. The moon is tidally locked to Earth, which is why we always see the same face. Many close-in exoplanets are expected to become tidally locked to their stars. Around red dwarfs, this matters because red dwarfs are common and their habitable zones lie close to the star. This is why tidally locked close-in planets belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terror of a tidally locked world is imbalance. One side receives constant radiation. The other side receives none. If the atmosphere is thin, the The day side may scorch while the night side freezes. Volatiles like water or carbon dioxide could migrate to the night side and freeze out, collapsing the atmosphere over time. If the atmosphere is thick, it may transport heat around the planet, creating violent winds and strange climate patterns. Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The science here is rotation, gravity, and heat transport. Tidal forces act like friction over long timescales. They take rotational energy from the planet and synchronize its spin with its orbit. Once locked, the planet's climate depends on whether air and oceans can move heat from the day side to the night side. Models suggest some tidally locked planets could still be habitable if their atmospheres are thick enough. But habitability would not make them comfortable in any simple sense. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. Imagine standing near the Terminator line, the border between permanent day and permanent night. The star would not rise or set. It would hang in one place, perhaps low on the horizon, forever. Winds might rush from hot regions to cold regions. Clouds might gather near the star-facing point. The night side might be frozen under a sky full of stars that never changes. The day side might be blasted by flares if the star is active. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like tidally locked close-in planets are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. Red dwarf stars can be violent, especially when young. They can produce powerful flares and high-energy radiation. A close-in planet may receive enough average warmth for liquid water, but also be exposed to atmospheric erosion and radiation bursts. This creates a strange contradiction. The most common stars in the galaxy may offer many small planets in the right temperature zone, but the same closeness that allows warmth can create danger. And after these worlds of permanent day and night, the final terrifying idea is not one planet, but the fact that the universe can keep inventing them. So, when we look at tidally locked, close-in planets, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. Tidally locked planets teach us that habitability is not simply distance. It is not enough to say a planet is in the habitable zone. We need to know its atmosphere, magnetic field, rotation, star activity, chemistry, and history. A planet can sit in the right zone and still be a nightmare. Or it can look strange and still perhaps support hidden forms of stability. The 12th terrifying planet is the one we have not discovered yet. Every few years, astronomy gives us a planet that sounds like it should not exist. A world hotter than some stars. A world darker than coal. A world orbiting a pulsar. A world losing its atmosphere to its star. A world wandering without a star at all. Each discovery expands the range of what the word planet can mean. From far away, from far away. The next terrifying planet is currently invisible to us. It may already be orbiting a star in the Milky Way. It may be crossing in front of its star tonight from our point of view, dimming the light by a tiny fraction. It may be waiting in data from TESS, from ground-based telescopes, from the James Webb Space Telescope, or from future missions designed to find worlds we cannot yet imagine. But distance is kind to almost every planet. Distance hides pressure. Distance hides radiation. Distance hides temperature. Distance hides the fact that a world can look calm, even when its atmosphere is a machine built by gravity and heat. NASA says we have confirmed more than 6,000 exoplanets, but that is only a tiny sample of the worlds likely to exist in our galaxy. There may be billions of planets in the Milky Way alone. Many are too small, too distant, too dark, or too hidden for current instruments to study in detail. That means the strangest planets are probably still unknown. This is why the next impossible world belongs in a video about terrifying planets. Not because the planet is trying to harm anything. A planet has no intention. It does not know it exists. It does not care whether anyone is watching from across space. But the physical conditions there are so extreme that the human mind has trouble holding them all at once. The terror of the undiscovered planet is possibility. We already know nature can make glass rain giants, lava super-Earths, doomed hot Jupiters, pulsar worlds, rogue planets, and dark planets that absorb almost all light. If that is what we have found with limited tools, what remains unseen? What kinds of atmospheres have we not detected? What kinds of interiors have we never modeled? What kinds of planetary histories have not yet entered scientific language? Now, the most important thing is not just that this world is dangerous. Every planet without Earth-like conditions would be dangerous. The important thing is why it is dangerous. The science of future discovery depends on methods. Transit observations reveal planets when they pass in front of stars. Radial velocity measurements reveal them by the gravitational wobble they induce in their stars. Direct imaging can catch young or massive planets glowing in infrared. Microlensing can reveal planets by the way their gravity bends light. Each method has biases. We find certain kinds of planets more easily than others. That means our current catalog is not a complete map. It is a flashlight beam moving across a vast, dark room. If you imagine a human explorer entering this environment, the story would not be dramatic in the way movies are dramatic. There would be no long chase, no careful footsteps, no heroic struggle across alien terrain. There would simply be physics, and physics would happen immediately. A human imagination wants categories: hot Jupiter, super Earth, mini Neptune, rogue planet, pulsar planet. But nature does not care about our categories. It builds transitional worlds, broken worlds, inflated worlds, evaporating worlds, carbon-rich worlds, metal-rich worlds, planets around binary stars, planets in crowded systems, and perhaps planets in environments we have not seriously considered. That is the frightening honesty of planets like this. They do not need monsters. They do not need storms with faces, or oceans with creatures beneath them. The planet itself is enough. The orbit is enough. The atmosphere is enough. The temperature is enough. The star above it is enough. But there is another side to this. Worlds like the next impossible world are terrifying, but they are also useful. They teach us what planets can become. They stretch our definition of what a planet is. They remind us that our solar system is only one quiet arrangement among countless possibilities. This is why the most terrifying planet in the universe may not be on any list yet. It may not have a name. It may not be in any telescope image. It may be too distant for current detection, or hidden by the glare of its star, or drifting alone where no star gives it away. But somewhere, physics is still working. Gravity is still gathering matter. Stars are still shaping orbits. Radiation is still stripping atmospheres. Collisions are still rearranging systems. So before we end, we need to return home, not because Earth is terrifying, but because after seeing these worlds, Earth becomes the strangest planet of all. So when we look at the next impossible world, we are not just looking at a strange world far away. We are looking at a warning about how narrow Earth's comfort really is. We are looking at a place where one or two small changes in distance, mass, atmosphere, or history have turned a planet into something almost unrecognizable. And this future planet, whatever it is, will probably remind us of the same lesson all the others teach. Earth is not ordinary, because planets are usually gentle. Earth is precious because the universe is capable of so many forms of hostility. There is another reason these planets matter. They make Earth look almost impossible. We live on a planet that is not too close to the sun and not too far away. It rotates fast enough to give us day and night, but not so slowly that one side bakes endlessly while the other freezes. It has an atmosphere thick enough to support liquid water and protect life, but not so thick that the surface becomes a pressure cooker. It has a magnetic field that helps shield the planet from charged particles. It has a large moon that stabilizes its axial tilt. It has plate tectonics and carbon cycles that help regulate climate over long timescales. It has oceans that store and transport heat. It has clouds that reflect sunlight and trap heat in complicated balance. It has a biosphere that changed the atmosphere and then learned to live inside it. None of this was guaranteed. If Earth had formed slightly closer to the sun, it might have lost its water or entered a more dangerous greenhouse path. If it had formed farther away, it might have frozen more deeply. If it had been too small, it might have lost its atmosphere more easily. If it had been too massive, its atmosphere and pressure might have become very different. If it had no magnetic field, the solar wind might have altered its atmosphere over time. If its early history had been different, life might never have gained a foothold. This does not mean Earth is magical. It means Earth is specific. It means habitability is not a single switch turned on or off. It is a long chain of physical conditions that must remain within certain boundaries for long enough that life can appear, survive, and evolve. When you hear about 55 Cancri E, you can think of Earth with the distance turned wrong. A rocky world too close to its star becomes a lava world. When you hear about Venus, you can think of Earth with the atmosphere and climate feedback turned wrong. A rocky planet with thick carbon dioxide becomes an oven. When you hear about Jupiter, you can think of planet mass turned far beyond anything human can stand on. A world becomes a pressure abyss. When you hear about rogue planets, you can think of Earth with the sun removed. A living planet becomes a freezing wanderer. When you hear about pulsar planets, you can think of a planetary system after stellar death. Worlds remain, but the meaning of sunlight is gone. This comparison is not meant to make Earth feel fragile in a hopeless way. It is meant to make Earth feel real. Earth is not the normal planet from which all others deviate. Earth is one outcome among many. It is a narrow island in a vast ocean of possible worlds. And this is why studying terrifying planets is not only entertainment, it is part of understanding habitability. Astronomers do not search only for Earth-like planets because they want to find a copy of home. They search because each planet teaches where the boundaries are. Too hot, too cold, too irradiated, too massive, too atmosphere-rich, too atmosphere-poor, too close, too far, too young, too old, too unstable. Every terrifying planet is a data point. Every hostile atmosphere helps scientists understand atmospheric physics. Every hot Jupiter helps explain planetary migration. Every lava planet helps reveal the behavior of rocky worlds under extreme stellar heating. Every rogue planet helps test planet formation and ejection models. Every pulsar planet stretches theories of how planets can form or survive after stellar death. So, as strange as these worlds are, they are not useless curiosities. They are laboratories. The universe built them. We study them. And by studying them, we learn the rules that also protect us. That may be the deepest reason these planets feel frightening. They are not separate from us. They are made of the same physics that made Earth. They are governed by the same gravity, radiation, chemistry, pressure, and time. The difference is not the laws. The difference is the conditions. The universe did not use gentle laws for Earth and cruel laws for other planets. It used the same laws everywhere. That means Earth is not protected by special physics. Earth is protected by circumstance, and circumstance can be rare. Let us imagine, very quietly, what a map of these worlds would look like. Not a map with borders, countries, and oceans, a map of danger. In the inner regions near stars, you would mark the furnace worlds, hot Jupiters swollen by radiation, lava super-Earths with molten surfaces, rocky planets whose atmospheres are stripped away, worlds so close that their years last only hours or days, worlds where one hemisphere is permanently turned toward the star like a face held near a fire. Farther out, you would mark the cold giants, planets with deep atmospheres and no surfaces, planets with clouds hiding pressure layers, planets where wind, chemistry, and magnetism create enormous systems no human could enter. The danger there is not always light and flame. Sometimes it is depth. Sometimes it is the fact that the more you fall, the less the planet resembles any place you have ever known. Around dead stars, you would mark the graveyard worlds, planets orbiting pulsars, planets around white dwarfs, planets that survived stellar evolution or formed afterward from debris. Their skies would not tell the comforting story of a main sequence star rising and setting. They would tell the story of what remains after a star has exhausted itself. Between the stars, you would mark the wanderers, rogue planets without suns, some young and warm enough to glow faintly in infrared, others old and cold, moving through the galaxy in silence. They may be more common than we once imagined. Most of them will never be seen directly. They are planets without sunsets because there is no sun to set. And throughout the galaxy, you would mark the unknown, the planets too small to detect, the planets hidden in glare, the planets whose atmospheres we cannot yet read, the moons around giant exoplanets, which may themselves be worlds, the planets in systems too distant for current instruments, the planets whose names do not exist yet. This map would not make the universe feel empty. It would make it feel crowded with possibilities. And here's the strange thing. The more planets we discover, the less ordinary the word planet becomes. Before exoplanet science matured, our solar system shaped human imagination. There were rocky inner planets, gas giants, ice giants, dwarf planets, moons, asteroids, comets. That already seemed diverse, but exoplanets broke the categories open. Hot Jupiters were a shock because our solar system has no Jupiter orbiting extremely close to the Sun. Super-Earths were a shock because our solar system has no planet between Earth and Neptune in size. Mini-Neptunes are common in the galaxy, but absent here. Planets around pulsars were a shock because they existed around stellar remnants. Rogue planets were a shock because they showed that planets can exist without stars. Ultra-hot Jupiters were a shock because they pushed atmospheric physics towards stellar temperatures. Again and again, the universe tells us not to confuse our neighborhood with the rulebook. This is why a video called "The Most Terrifying Planets in the Universe" can never really be complete. There will always be another world, another system, another observation, another planet that sounds impossible until the data confirms it. In a way, this is comforting. Not because the planets are friendly, but because the universe is still capable of surprising us. The night sky is not a finished picture. It is an active field of discovery. Every star may have a system. Every system may have a story. Every story may include worlds that stretch language. And perhaps somewhere, around a quiet star, there are planets not terrifying at all. Worlds with oceans. Worlds with clouds. Worlds with continents. Worlds where chemistry has become biology. Worlds where something looks up and sees its own sky as normal. But tonight, we are not focusing on those worlds. Tonight, we are focusing on the ones that make us grateful for the ground beneath us. The lava worlds, the glass rain worlds, the pressure worlds, the dead star worlds, the starless worlds, the dark worlds, the doomed worlds. They are terrifying because they are real. And they are real because the universe is larger, older, and more inventive than our instincts were built to understand. There is one more layer to this story, and it may be the most human one. Why do we want to know about these places at all? We cannot go to KELT 9b. We cannot stand on 55 Cancri E. We cannot fly through the glass storms of HD 189733b. We cannot walk on a rogue planet drifting between stars. Even Mars, our nearby neighbor, remains incredibly difficult to reach. The planets in this video are far beyond any practical human journey, and yet we study them. We build telescopes. We launch observatories into space. We spend years measuring tiny dips in starlight. We compare spectra. We model atmospheres. We argue over data. We name worlds that no human will ever touch. This is because knowledge does not require ownership. We do not need to land on a world for it to matter. We do not need to survive there for it to teach us something. A planet can be forever unreachable and still become part of human understanding. There is something beautiful about that. The universe is filled with places that are not for us. Most of it is not survivable. Most of it is not reachable. Most of it will never become human territory, but it can still become known. In a way, terrifying planets are humbling. They tell us that exploration is not always conquest. Sometimes exploration is simply looking carefully, measuring honestly, accepting what the data says, letting a distant world remain itself instead of forcing it into our hopes. And what the data says is often more imaginative than fiction. Fiction invented lava planets, dark worlds, lonely wanderers, and dead star systems. Then astronomy found real examples that were stranger because they came with physics behind them. A fictional planet can be dramatic in any way the writer chooses. A real planet must obey the laws of nature, and somehow, obedience to those laws has produced worlds more extreme than imagination would have dared to make. A planet where the year is a day. A planet where the star tears it apart. A planet where the atmosphere may rain glass. A planet darker than coal. A rocky world with a lava ocean. A planet orbiting a pulsar. A planet without any star at all. These are not random concepts. They are measurements. They are systems. They are places. And maybe that is why they stay in the mind. Because once you know they exist, the night sky changes. The stars no longer look like simple points of light. Each one may have planets. Some may be gentle. Some may be dead. Some may be violent. Some may be impossible by human standards. Some may still be waiting for discovery. When you look at a star after hearing about these worlds, you are not just looking at light. You are looking at possibility. Around that light, there could be a scorched giant, a frozen rogue that once belonged to the system, a lava super-Earth, a dark planet, a mini Neptune, a small rocky world in permanent twilight, a moon with an ocean, a planet slowly losing its atmosphere. The sky becomes deeper, not because it changed, but because your imagination has more accurate information. That is what astronomy does. It does not make the universe smaller by explaining it. It makes the universe larger because every explanation opens another door. And tonight, the door opens onto terrifying planets. Before the final reflection, let us pass over the journey one more time, slowly, because each planet carries a different kind of fear. Venus is the fear of atmosphere. It tells us that air is not automatically gentle. The same thing that allows breathing on Earth can become crushing pressure somewhere else. The same greenhouse effect that keeps Earth warm can become a trap. The same clouds that look soft from a distance can be made of acid. Venus is terrifying because it is near, rocky, and familiar in size, yet completely hostile at the surface. Jupiter is the fear of depth. It tells us that not every planet is a surface with a sky above it. Some planets are sky all the way down until the sky becomes something else. A human mind wants a floor. Jupiter refuses that. It replaces land with pressure, and pressure with transformation. KELT 9b is the fear of heat taken beyond common sense. It is not just hot in the way a desert is hot. It is hot enough that atmospheric molecules can be torn apart. It is a planet forced into extreme behavior by its star. It teaches us that a world can exist in a state where chemistry itself is under constant assault. HD 189733b is the fear of false beauty. It looks blue, and blue makes us think of home. But its blue is not Earth's blue. It is not ocean. It is a warning that color can lie to the imagination. A planet can wear the shade of habitability while hiding winds and glass-like storms. 55 Cancri A is the fear of molten ground. It tells us that rock is not always solid. A planet can be rocky and still have a surface, more like a furnace than a floor. It takes the most stable material in our everyday lives and turns it into something fluid, glowing, and dangerous. WASP 12b is the fear of being too close. It is a planet in the grip of its star. Its danger is not only weather or heat, but destiny. The orbit itself is part of the destruction. It reminds us that sometimes a planet's doom is written not in its surface, but in its path. TRES-2b is the fear of darkness that is not cold. It absorbs light. It refuses brightness. It may glow faintly from heat while remaining darker than coal. It teaches us that darkness can be active, not empty. A planet can be black because it is swallowing light. The planets of PSRB 1257+12 are the fear of surviving the death of a star. They orbit a pulsar, a stellar remnant. Their existence feels like a ghost story written in orbital mechanics. They remind us that planetary systems can exist even after catastrophe, but the result may be a system bathed in radiation from an undead star. Rogue planets are the fear of loneliness. No sunrise, no year around a star, no warm disk of light in the sky. Just a world moving through the galaxy with the stars as distant witnesses. They show that a planet can be separated from the very thing we associate most strongly with planetary life, a sun. Neptune and Uranus are the fear of hidden interiors. They look calm from far away, but beneath the clouds are pressures and chemical states that stretch imagination. They remind us that even in our own solar system, the familiar names are not fully familiar worlds. Tidally locked planets are the fear of a stopped sky. One side, always day. One side, always night. Maybe a permanent twilight ring between them. They show that a planet can have warmth and still be strange, that even a potentially habitable location can produce an environment unlike anything humans have known. And the undiscovered planets are the fear of the unknown. Because every time astronomy improves, the universe becomes stranger. The next terrifying planet may already exist in our data. It may be waiting for a telescope, a spectrum, or a careful measurement to turn it from a shadow into a world. Together, these planets form a kind of cosmic lesson. They are not all terrifying in the same way. Some burn, some freeze, some crush, some darken, some wander, some are stripped away, some orbit the dead, some simply refuse every human expectation. And that variety matters. It means the universe is not hostile in one simple direction. It is hostile in many possible directions. There are many ways for a planet to be wrong for us, and only a narrow set of ways for a planet to be right. That is why Earth feels different after this journey. Not because Earth is perfect. Earth has disasters, storms, extinctions, volcanoes, ice ages, and dangers of its own. But Earth remains within the fragile range where liquid water can cover the surface, where air can be breathed, where pressure does not crush us, where rain is not glass, where rock is usually solid, where the sun warms without tearing the planet apart, and where night eventually ends. Every terrifying planet in the universe points back to that fact. Home is not ordinary. Home is balanced. So let us come back to Earth. Right now, wherever you are, there is probably a floor beneath you. There is air around you. There is a temperature your body can tolerate. There is pressure your lungs evolved to breathe. There is a sky above you that changes slowly from day to night and back again. There is weather, but it is weather within a range life has learned to survive. This feels ordinary because you have never lived anywhere else, but after crossing these worlds in the imagination, ordinary becomes extraordinary. On Venus, the air becomes a crushing furnace. On Jupiter, the ground disappears. On KELT 9b, molecules are torn apart by heat. On HD 189733b, beauty hides glass rain and brutal winds. On 55, Cancri E, rock itself may become an ocean. On WASP 12b, a star slowly tears a giant planet apart. On TRES 2b, darkness becomes a planetary identity. Around PSRB 1257 plus 12, planets orbit the remnant of a dead star. In interstellar space, rogue planets drift without sunrise. On the ice giants, pressure may transform chemistry into something alien. On tidally locked planets, day and night may stop moving. And beyond all of them, there are more. Planets we have not found. Planets with atmospheres we have not decoded. Planets with surfaces we cannot imagine. Planets that will force future scientists to invent new categories. This is the universe we live in. Not a universe of simple worlds arranged neatly around stars. A universe of extremes. A universe where gravity gathers matter into forms both beautiful and hostile. A universe where the same laws that made Earth also made worlds no human could survive for a second. That is what makes these planets terrifying. Not that they are evil, not that they are waiting for us, but that they are natural. They are what happens when physics is allowed to run under different conditions. They are what happens when distance changes, when pressure rises, when atmospheres thicken, when stars burn hotter, when orbits shrink, when radiation intensifies, when planets are thrown into the dark, when a star dies and something still circles the corpse. And maybe that is why space documentaries feel so powerful at night. They remind us that the universe is not built around human comfort. It contains beauty, but not safety. It contains order, but not mercy. It contains worlds that shine, worlds that burn, worlds that freeze, worlds that vanish into darkness, and worlds that reflect almost no light at all. And still, from one small planet, we can know about them. We can measure their shadows. We can read their spectra. We can notice their gravitational pull. We can detect their faint heat. We can give them names. We can tell their stories. That is the human part of the universe. Not that we can survive everywhere. We cannot. Not that the universe is gentle. It is not. But that we can understand places we will never touch. And perhaps understanding is its own kind of journey. We may never walk on these terrifying planets. We may never see their skies with our own eyes. We may never hear their winds, feel their heat, or watch their stars rise. But through science, light, and imagination, we can travel there for a while. We can approach the glass storms, the lava oceans, the dark giants, the dead star worlds, and the lonely planets between suns. Then we can return, quietly, to Earth. And when we do, the simple things feel different. A breathable room, a normal sky, a planet with ground, a world where rain is water, a sunrise that returns. After seeing what planets can become, Earth no longer feels ordinary. It feels like a narrow, fragile, beautiful exception. And that may be the most terrifying truth of all.